Hi, my name is PK Gulati. I'm the founder of The Assembly. If you're here, you're probably watching an assembly workshop. We do these workshops every week, and these are prepared by the assembly team in Dubai. These workshops cover ideas from data sciences, hardware design, automation, robotics, drones, and all the other exponential technologies that you can think about. The idea is for us to learn more than what curriculum teaches us. And we are trying to bring people to start working with their own hands with these technologies which have the capacity of changing the world. So welcome to this workshop and learn more about new wonders, what you can build.
Hello everyone and a very good morning. Welcome back to another session. Communicating in an encrypted way, besides being so fascinating, has many applications in various fields. One of the most common methods of encrypted communication is Morse code. And in today's session, we will show you how you can make your own Morse code translator using just Arduino. So let's get started. Alright, so before we begin our workshop, let's talk a little bit about the assembly. The assembly is basically a smart lab based out of N5 since December 2014. And over the course of around 7 years, we have provided over 300 free workshops. Now, these workshops are divided into three categories, which is hack, code, and data science workshops. Now, hack workshops deal with are the workshops that involve the use of any hardware like Raspberry Pi, Arduino, or any other hardware for that matter, and include IoT workshops and other embedded system workshops. Code workshops, on the other hand, are solely code based, involving the use of different or new APIs, frameworks, creating apps, games, etc. Data science category is quite self-explanatory, deals with topics such as AI, machine learning, big data, analytics, etc. Our target audience are students, entrepreneurs, and professionals, but we are more than happy to welcome anyone who is interested in technology. And you can know more about us or follow us on our forum, which is members.theassembly.ae. Also, don't forget to check out our social media. We are there on Facebook, Twitter, Instagram, and YouTube by the handle of @MakeSmartThings. So yeah, let's get started. So what's Morse code? In the past times when communication were not as simple as today, one of the most common ways of communicating was Samuel Morse's method called Morse code. In this method, each letter and or number represented by a short dash or long dashes, which are basically used to cipher the text into an encrypted message and can be used for communication between the two parties. Now, Morse code, like any other language, has its own alphabets and is currently available in both the American and the international types. And this is the image here shows the international type of Morse code, and each dot and dash, like every different alphabet and number, is represented by a series of dots and dashes. So it can be seen that the message SOS is represented by three dots, three long dashes, and three dots, because S is represented by three small dots, O is three long dashes. So this way we encrypt the message and then it's decrypted by the person who's receiving it. Now, Morse code can be transmitted in different ways. Originally, it was transmitted as electrical impulses along the telegraph wire, as it can be seen from the image. Like this device was used back in the days to send or to transmit Morse code. But it can also be used to send, also be transmitted as an audio tone or as a radio signal or as a body language frequency and much more. Now you can imagine that the dot as a time, as a unit of time, and then the dash is three times that. So the dash is three times longer than the dot, and then the distance between the parts of the letter is a unit of time, and the distance between two consecutive letters is 3 units of time. And similarly, the distance between the words is 7 units of time. For instance, the word SOS, which is the worldwide standard for requesting help, is dot 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 dash 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 dot 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 in Morse code. So is Morse code still practical? Yes, it is used in aeronautics, while it not be much used, but it's still used in aeronautics for navigation, and especially ships use them for communicating with the control tower and signaling. So they use light waves, so they use light to signal or ask for help to the control tower. So what are the requirements for today's workshop? So what we will be doing is essentially we'll be passing in a string, and that string will be converted into Morse code, and we'll receive output in two forms. We'll receive audio output by using a buzzer, and we will receive a visual output by the use of the LED. Now the requirements are pretty simple. We obviously need an Arduino Uno. We need a buzzer for getting the output, an LED, this can be any color of your choice, and a resistor. 220 ohms resistor is preferred, but if you have any other bigger value, that might as well work, but it might decrease the luminosity or the brightness of the LED, but it's fine. And yeah, so let's get started.
Alright, so let's start with the wiring. The wiring is very straightforward and there's nothing complex about it. So here we have our LED with its two legs. The long one is the positive one and the other one is the negative one. So we take our LED and plug it into our breadboard. You can just put it anywhere you want, and then our resistor, you can use a 220 ohm resistor or a higher resistor is fine as well, as long as you have a resistor, it's fine. And connect the resistor to the negative leg of the LED and put it to the ground. Now we are off to the final connection, which is the buzzer. So the buzzer has two pins, the positive and the negative. So connect the negative end to the ground, and the positive end of the buzzer is connected to pin number 8 on the Arduino board. So here we have the digital pin 8, we connect our buzzer over there. Now as for the positive end of the LED, since we want to control it from the Arduino code, we will be connecting it to pin number 13 on our Arduino board, which is right before the ground pin on the Arduino. And finally, to finish off our connection, we will connect the ground pin from the Arduino to the ground on our breadboard. And yeah, that's it. This is our wiring, and now we can connect this to our laptop and upload the code.
Okay, so let's start with the coding. So first we have to declare some variables that we'll be using throughout the code, and let's start. So we'll declare a constant int LED. So this will be the pin number of the place where we are going to connect to. We are going to connect the LED to the Arduino board. In our case, we'll be connecting it to pin number 13. So we'll give 13. Then similarly, we will also create a constant int for the buzzer, and we will give it pin number 8 because that's where we are going to be connecting our buzzer to the Arduino board. Then we will create a string code, and this will be used to store our code that the user types in or the message. Then we have the length. This will use in the code later, and we need ways to store the characters that the user inputs. So we'll create a variable called character, the new character, and then we will move to creating a variable to store the time delay. So let's do that quickly. So we create a character ch, and then just create another one, and this okay, this variable that we are creating, unit delay, is the amount of delay that we want to be there between when the dot comes and goes. So this is the time delay that we want. So we will take it to be as 250, and yeah, that's pretty much it for the variable declaration part. Now what we need to do is we need to create methods, so that when we call that method, so we need to create methods for the dot and the dash method. So when it is the dot, when we call the dot, the LED needs to light up for a particular time, and then be off. Similarly, with the buzzer needs to sound for that particular amount of time and then be off. So we'll create a method called dot. So what this dot method will first do is it will print on the serial monitor that we are printing a dot, so it will just print a dot. Then it will say digital write, so it will write and it will turn on the LED, so that is digital write, and then turn on the LED which is connected to pin 13 as high. And basically it will do the same thing for the buzzer as well, so I'll just copy and paste it. So instead of LED this time, it's the buzzer that's getting turned on. And now we want it to be on for a certain amount of time, that is our unit delay, and we want it to be on for that amount of time, so we'll say delay and unit delay. Now we can pass in the 250 directly as well to the delay method, but creating a variable to store the value allows for us to, later when we decide to change the value of the delay, or when we want to play around with different values, we don't need to change it everywhere in the code. We can just change it in one place and then have it all there. So we just do it that way. And yeah, now that our LEDs are turned on, we need to turn them back off after the set amount of time has passed. So we'll just turn them back to low. So do the same for the buzzer, and again finally we have our delay, unit underscore delay. Alright, so we'll code our dot. So we've done our dot method. We'll do the dash method very similarly. So dash, but the thing with dash method is it will be longer than the dot. So if the dot is delayed 250 seconds, 250 milliseconds, we would want the dash to be, each single dash to be delayed, or to have a duration of at least 3 times the dash, so that we know that it is a dash and that is a dot. So for the dash, again we'll start by printing the dash on the serial monitor. So we'll start with serial dot println. Okay, I think I missed the ln over here. Let me just add that. Okay, serial dot println and the dash. Then what we will do is, again as we did for the dot method, we'll turn on the LED, turn on the buzzer, delay for amount of time, turn them back off, and delay for the same time. So let's just we can just copy this right from here and paste it over here. So LED is turned on, buzzer is turned on. Okay, now the difference over here is in the delay line. So we don't want to delay just by 250 milliseconds, we want to delay by 750 milliseconds, so that is 3 times the unit delay. So that is what we are going to be doing here, and again we multiply this by 3 as well. Right, we're pretty much done with the code, like apart from some other stuff, but yeah, we're almost halfway there. Now next what we need to do is we need to enter the codes, or the Morse code representation of each letter and number. Now this is a lengthy process, so I recommend you just copy paste this part. So I'll code one method and then I'll copy paste the rest, so that you can also copy paste. And anyways, the code is provided in the link in the GitHub link in the description below, so you can download the code and copy paste if you want to follow along. So for A, the international Morse code representation of A is a dot and followed by a dash. So dot dash represents an A. So that is what we are going to be doing here. So we'll first call the dot method, which will print a dot on the serial monitor, turn on our LED and buzzer for the specified amount of time. Then between the dot and the delay there should be a small time delay, otherwise there is no way of making out whether this was these two were together or they were meant to be separate. So dot, and then when you have a delay, so a delay of unit underscore delay, and finally we have the dash, and we'll call the delay once more, unit delay. Now we'll follow a similar method for all the other alphabets and numbers. So we'll go from A to Z and 1 to 9, 0 to 9. So I'll just go ahead and copy the code for these numbers, for numbers and alphabets, and paste them here just to save on some time. And like I said, the code will be there in the description, is there in the link in the description, so you can just copy it from there and run it on your systems, or if you want to follow along you can paste the code. So these are all the code, all the methods for the different alphabets and numbers. So we have A, H, I, J, K, all different, represented by different series of dashes and dots as per the International Morse Code. Okay, so now that we have done this, what's next? Now we need a method to read the input from the serial monitor, and then convert it into the Morse code representation. And for that we first need to have a method that actually checks that if it's this character, then this letter is to be printed, or this method is to be called. So we'll do that right now. So we'll create a method called Morse, which is basically doing our translation for us. And this method, what it does is okay, this method, okay, wait, why can't sorry, my cursor is missing. Yeah, this over here. Right, so in this method what we are trying to do is we are trying to check if the character is equal to a certain letter, then we are calling that character's method. So it's basically we are printing the Morse code for that character. Otherwise we are checking if it's another character and printing the Morse code for that character. So we'll start off by checking for character A. So, and don't worry about the character, we'll get these characters from the serial monitor. So we'll do the code for that as well. So we'll check if ch is ch is the variable for our character. So if ch is equal to A, then, or if the c is equal to, the character is equal to A, or if it's equal to the small a, like it's not capitalized, then we will call the a method. So this is what we declared above. So if you remember, we did over here that a is represented by a single dot and dash. So this will go into the a method, call the dot and dash method, which will print it on the serial monitor and also light up and sound a buzzer. And once we call that method, we also want to print a space so that it does not cramp everything together. Serial.print and add a space there. Now we'll follow a similar method for the rest of the letters as well. So we'll just have to do a series of if else to check if the letters are equal, and same thing with the numbers. So again, you can just copy paste this code for a couple of times, so you can change the a with b and c and so on, and that keeps on going until you reach the end. Okay, so we'll paste everything here, and here we've got all the characters from a to z and then 0 to 9. But that's not all. Now what we want is, what happens if a person enters a space, like if there are 3 different separate words in a in a phrase like this is my name, the 4 words, then they will be separated by space. And if they're separated by space, what should happen? So for that we need to say that else if the character is equal to the space, then there should be something that is done, and that would be like as I told about it in the presentation, that we will add a delay which is 7 times the unit delay. So unit underscore delay times 7 to signify that a word has ended and now it's a new word that's going to start. And we can print a forward slash, so we can say serial dot print, and we can add in our forward slash in this, and not to forget the semicolons. Okay, I think we missed a semicolon somewhere, semicolon, or okay, we missed a semicolon over here, right? So after we're done with this, one last thing that we need to check is for the enter. So once we have typed in the code, or sorry, the sentence on the serial monitor, we can then hit the enter button and get the Morse code translation for it. So we just need to add this lines so that it does not give us an error when we press the enter key. So we will say that if the character is equal to the backslash n, which is also equal to the new line, then it will say serial dot println, and it will just print nothing. So it will just be nothing. And finally, if there is any other character, then it will just print unknown character. For example, someone enters a quotation mark or question mark or some kind of other character that is not coded for here, then you can just say that it's an unknown character. So you can say serial dot print, okay, sorry, so it's serial dot println and then unknown character. Okay, right, unknown character. Then the final method is our string to Morse method, which is doing our conversion. So we can go here. Okay, wait, let me check. Okay, this is the bracket for the Morse one, so we'll just close it here and go down. So it's the void string to Morse, and this method will take the code, so sorry, the sentence, so it will take length equals code dot length. So code is basically what the user enters in, and it will take the length of that and it will run a for loop for that length amount of time. So for int I equals 0, I is less than length I plus plus, the basic format of the for loop. And for every time it runs a for loop, it will get the character at that particular instance of the phrase, and it will call the Morse method on it. So what this is doing is reading it's getting the sentence that the user has typed in and looping through each character and calling the Morse method on it. So we call the Morse method on that. So yeah, and okay, before we call the Morse method, we first need to get the character itself. So to get the character, it's pretty simple. We can just say code dot char at, and we can pass in I. So it will get the character at the I position every time. So it will start from 0, 1, 2, 3, 4 and go till the length of the string. So however long that long the string is. And yeah, finally we can go to our setup method. So the setup method will just initialize some basic stuff. So we'll say for void setup, we'll start our serial monitor at a baud rate of 9600, So it's a serial dot begin and 9600, and we also need to set the pin modes. So remember, we had initialized our LED and the buzzer in the beginning of the code. We now need to set whether they will be input or output. So of course they are output, so we'll set that. So we'll say pin mode and pass in the name. So LED and LED will be output. So output, and then we can just copy this line of code for the buzzer as well, and just change the name from LED to the buzzer. Correct. And then we can give a short message to the user, so we can type in serial.println. We can say, please type your message here. Okay. Alright, so pretty much the last method which is remaining is our loop method, and what we will do in our loop method is we'll be constantly reading the serial monitor to check if someone has entered something, and then we'll convert it to our Morse code. So we'll translate it into the Morse code. So we'll go create our loop method, and within our loop method we will have a while loop which is reading for the serial. So it's saying while serial dot is available, okay, let me just, yeah, okay. So while serial is available, it will read the code. So code will be read via the serial monitor. So serial dot read string, this will give in the text entered by the user, and we can also print it to the user to inform that this is what you had entered and this is what the Morse code for it looks like. You can pass in code over here, and finally once we are done with it, we can also do this code plus and then add an equals to. So your code equals, and then it will be followed by the Morse code, and then we can call in the string to Morse method that we just coded above, and this will basically translate the Morse code by getting the character from the individual by getting the character from the string that the user has passed in and calling the Morse method on each of the characters. And finally we can add a new line at the end. And one last thing that we need to do is we need to add a delay after this. So we'll add a delay of 1000 microseconds, 1000 over here, and yep, that's pretty much it. So yeah, that's it for our code, and now we can verify our code. So we can, okay, it's done compiling. So let us plug in our Arduino. So let's plug in our Arduino. So my Arduino is now plugged in, and let's try uploading the code to the Arduino. Okay, yeah, one thing I forgot to mention before uploading the code is you need to make sure that you go to the tools and select your board and make sure that it is the correct board. In my case, I'm using an Arduino Uno, so this is the board that I'll be using. However, if you're using Arduino Nano or Mega or any other Arduino board, you can choose the correct type of Arduino board from here. And the other important thing is you make sure that you select the COM port. So you need to select the correct COM port. So in my case it's the COM5. I'll select it and then upload the code again. Now that the code is uploaded and the wiring is also done, we'll plug in our Arduino and open the serial monitor. So make sure that the Arduino and the serial monitor are on the same port, so make sure you have the correct port selected. Once you have the correct port selected, it says please type your message here, and you can type a message. Now before we actually type a message, we can go to a website over here and see what output it gets. So if you have the input as SOS, the output are 3 dots, 3 dashes and 3 dots. And yeah, so let's check this on our code that we have done. So we're coming back to our code over here. Let's type in SOS and press enter, and let's check the output. Alright, so as you just saw that the LED was blinking and the buzzer was sounding every time. The code on the serial monitor, you can see that it printed dot 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 dash 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 dot dot dot. Though I think it printed every one of them on a new line, which is something that we can easily change. I think in the method over here, instead of print ln, we should have just used print, and we can upload the code again and try it later. Try again. Okay. Okay, now it's done uploading again, and let's try again this time. Let's try something else. Let's try the assembly. Okay, let's see what output it gives. Well, that was a pretty long message, but yeah, as you can see in the console, the over here the serial monitor, it's now printing it properly, and you can see that after after the word, which is the and then the assembly, it printed a slash in between, and there was a delay, as you could see or notice when you were hearing the buzzer, that there was a delay between the two words, and that is what we did when we multiplied the unit delay by 7 to account for spaces. So yeah, it's working as it's supposed to, and yeah, that's it. So that's it for today's video. I hope you guys enjoyed it and got to learn something new. If you did, be sure to hit the like button and consider subscribing to our channel if you want to be notified of any new videos that we upload. And yeah, my name is Amar, and I'll catch you in the next one.